Perfect. So today's class is Oscar and me and Josep. It's going to be a more hands-on class, not that much theoretical. We will go about the different type of mechanism, G-code, and tomorrow we will assemble one of the small 6-pack milling machine, and we will have the opportunity to play a little bit with the machines. So you understand what is inside this black box that are right now most of the CNCs, 3D printer, laser cutters. The assignment for this week, and actually the next week also, that is Easter. So it's a 2 weeks assignment. Next week there is no class because it's the Easter break. So you have 2 weeks to do this assignment. It's working groups, usually groups of 3 people, 4 people. So in case of Ivan and Tatiana, you can work together, and Kurt and Isabel too. Mayra, I don't know if you can join the Lima team. So we can talk it then tomorrow afternoon. Mark, you can join like some of the people here in the lab, or that also usually happens. Like in case you don't have anyone, you can also make your own 1-person team in case you want it, but it's more complicated because basically you have more work to do. Okay, perfect, Mayra.
Maybe we could give a little bit of context of why is this happening now. Okay, so this week is machine week. This is on. This week is the machine week, and traditionally this week is much further down the academy. For this week, you normally need to know about sensors, about actuators, about these things that we will do. This year has been shifted and will be in 2 weeks from now or 3 weeks from now. But the global schedule has changed so that you have the possibility, in case that there is any lockdown or any closure of educational facilities again, as happened last year, that you have a machine with you that you can build yourself or that you can modify at home in case anything happens. Doesn't seem that is likely, but as we are a global program, we need to, let's say, understand that other parts of the world might close down, like in the States or somewhere else. So we have to coordinate with the rest of the world. And that's why we are doing a machine week that normally is in May, and we're doing it in March. Okay. Is that more or less understood for everyone? So this week, there's going to be a lot of things that are going to sound very weird and that pedagogically don't make sense right now, at least from my point of view. But we will go through it and try to extend this week a little bit into, let's say, farther into April as well, so that you have some time to understand all this. And a lot of things will make sense during outputs and things like this. Just stay with us. It's not the best, but it's the way we have to do it, at least for this year. Okay. So, sorry, that's. No están haciendo la pantalla de momento, para preparando. Tranqui, ya está. Me conecto sin internet.
So just to give a little bit of context of what is this week, I just went to 2016 hide video upload and make it one to the panel. Okay, I just went to other years of the academy. What we didn't went to 2020 because it was a really weird year, and some machines were then by just one person. Some of them they were not specially finished. So last year was a little bit more flexible on the machine week. So let's take a case study of 2020, 2019. This is IPG machine, and this is not the machine they built. This is one of the machines they took as example to learn try to understand how mechatronics works. So basically, the video is a little explanatory on how they build a machine. So I was explaining, showing you some example of past years. So for example, let's see. I don't know this machine. And this is basically a machine that a lot of the machines are actually games, like they're not specifically like CNC machine or a laser cutter machine or a 3D printer machine. It could be easily a like for example, a pizza cutter or like a drawing machine with pushes. Like it could be a stamp machine. We have seen some years, like I think it was Kamakura, that basically made a ketchup dispenser for hot dogs. That could be the machine that's as crazy as you want. Doesn't to be like completely fully functional, like 0.1 microns accuracy. Could be like in the easily like 5 millimeter accuracy. Of course, this week is about trying to make something that is work as much as possible and as accurate or as much planned working as they want. For example, 2018, 19, our students didn't make a machine per se, they need a scanning booth. So we have checked in the 3 scanning week that for using the Kinect, you need to move the Kinect manually around your object. So in this case, what happens if you're alone? So the students make a rotating platforms and a vertical pole that moves the Kinect automatically around someone. This is just a machine. So they create a little interface with processing to create scan and actually start moving the Kinect up and down and rotating. In this case, it was DR with a big motor. So actually, like creates vertical movement to scan you. Could be something that has utility or something that doesn't. Completely up to you. For example, in this case, this group, they make a CNC machine. Probably, usually this happens in labs where they are planning to upgrade the equipment. So they buy the components that usually is like a big shopping list, and the students assemble the machine or they design the machine with instructors. It's a combined work. For example, Digiscope, this is a self-knitting machine. In the video, they don't show it completely working. Electronic-wise, it's not mandatory to make your own electronics. You can use out-of-the-shelf components. So that simplifies a lot. Of course, like designing the electronic components for machines usually not that straightforward and has like complexity. So in this case, we will show you some examples of electronics, like out-of-the-shelf electronics that you can use. We also have like custom design that we built in the house for last year. In here, you can mix all the techniques you want: CNC, laser cut, of course, molding and casting. But right now, you haven't not go to molding and casting, so I will not encourage you too much to go because it's not the moment to go really experimental. Materials that usually widely used. Since from 2015 to 2017, actually, most of the machines were using cardboard. And actually, there's a cardboard system that works really well to make machines. That is a modular system of rails made out of cardboard. Why they use cardboard? Because it's really fast to produce a lot of modifications of the same file. And if you make folding structures, it's still strong enough. For example, that is a, ¿cómo se llama? MTM? No, lo de Nadia Pic. Nadia Pic, modular machines, cardboard stages, yes. So from 2015 to 2017, most of the labs, they use like a straight aluminum poles with bearings, and they make a frame made up of cardboard. Nadia Pig, that is one researcher in the MIT, developed it, and basically all the labs were fabricating modules of linear rails, and they were combining to create different tools. Like you start with a simple system and you start like overlapping X, Y, Z, or you can combine two X and one Z, and like that. That implies that you can, with a simple system that is create one linear array that is one of the standards for making any movement in machining, you can combine to have multiple outputs. So actually you can combine it to create multiple machines. And we can see some example. ¿Eran 17 o 16?
Okay.
Lo de los stages.
No.
So here we saw in 2016, I think it was, let's go, I think it was 16 or 15, that there were a lot of machines. I know Seoul for sure. So gamma machine. In this case, they created, for example, it was a Korean drawing machine, I think. And they actually produced the files, for example, with the software for the CNC. But instead of having a motor, they just have a pen. Actually, they were like clever enough to don't overwork on the software because they were not really skilled. So, 2015, let's go to 2016, and it was better. They made also one of the requirements for this week is to create a new repo for the machine and document all together. And you need to make a documentation between all the team and also establish what is your individual contribution. Like I focus, for example, on trying to debug the software. I focus on trying to debug the hardware, or I focus on the tool, etc. So these guys, they created a oil painting machine. So basically it's also a XY plotter, but with different syringes that were pushed with different colors on top of a water bath. And with a paper, you let it drop on top of the water and gets impregnated by the oil, with the color oil. So they put the paper and you have a Miro artboard. Santi can tell it. Let's look for the machine of because Barcelona pizza cutter will show up. Yeah, pizza cutter. In this case, for example, there was a like box that has a rotating platform and has just one ray that has like the traditional pizza cutter attached to it that you just cut in the slices all the time. The documentation from 2016 to and back is not awesome, I have to be honest. This is the EAD. Last year, for example, they made a scarlet that is not that standard traditional fabric machine, like complex to fabricate. So their was not really good, but they achieved to move a scarlet. That is already a huge job. It was a light painting. Don't know what is this. Okay, it's a machine that rotates. Okay, we can buy.
American. Lovely tomorrow.
It's a pick and place machine, seems like. Interesting. Random root. Okay, for example, this is another drawing machine. This one, like, I think it's a coffee maker or a water dispenser machine. As far as I remember, there was one that they make a cocktail machine. So basically, it has like the gin, the tonic, the ice dropper, and then a stirrer to move it.
¿Qué requirements tienen para estas tienen que hacer su propia electrónica y todo?
No.
Este año no.
So